Hey, what's up, all you mathematicians? Today we are going to be looking at the last section of Chapter 10. It's actually a very short chapter, just the 4 sections. And so we've done the quadratic formula. The last thing we're going to do is we're going to look at graphing quadratic equations. So all of these quadratic equations, when you graph them, they're going to be nonlinear. They're going to be a parabola. So that's going to be some kind of U shape, or if it's upside down, the N shape looking graph. Um, so you do a few things. It takes a little bit of work, not too much. So the vertex is the first thing you're going to find, and the vertex is either the lowest point if it's a U shape or the highest points if it's the N shape. And you find the vertex. So let me just draw that, by the way. The vertex is the lowest point or the highest point. So that would be the vertex. And it's called that. It's identified because it's kind of the mirror point. If you look at the vertex and you go up the left side, it's the mirror of the right side if I would have drawn a better looking parabola. So to find the vertex, it's the opposite of b over 2a for the x part of the point. For the y part of the point, you have to plug that in to the x and then just do the equation. So not too bad. To find the intercepts, to find the x-intercepts, we'll do the cover-up method. We'll cover up anything with an x and then find y. And then for the y-intercepts, we'll cover up the y and then solve it for x. So that one takes a little bit of work, and then we'll plot all those points. And then if we need some more points, we'll just plug in some numbers that are convenient for us. And it should be a nice smooth curve. And then it says, keep in mind, if the squared term is positive, it's going to be the U shape. If the squared term is negative, it would be the upside down parabola. And by the way, that's the vertex still. Okay, and then we'll also just talk briefly about the domain and range of each problem. Okay, so I just have 4 examples here. We're going to do them, and it shouldn't be too bad. So the first thing we're going to do is we're going to find the vertex. So that's the opposite of b over 2a. So the opposite of b would be 6, so vertex. So 6 would be the opposite of b over 2 times a. Remember, a is 1, so 6 over 2, it would be 3 for my first part of my vertex. To find the y part of my vertex, we're going to have to plug that x into the equation. So that would be 3 squared would be 9, minus 3 times 6 is 18, plus 8. I hope you follow along with that. So 9 plus 8 is 17, 17 minus 18 is negative 1. So my vertex is at 3, negative 1. So I'll go ahead and plot that. 1, 2, 3, down 1, right there. So there's my vertex. Now I know this is going to be an upward U because my first term is positive. So I know that this is going to be my lowest point of my graph and everything is going to be above that. Okay, so to find the intercepts, the first thing we'll do is if you remember from, I think it's like chapter 3 or something, the cover-up method. So anything with an x will cover up, and that will be our y-intercepts. So if I cover up the x's, that would cover up the x squared and the negative 6x. It says, if you look at that, it's kind of hard to see, but it says y equals 8. So there's my y-intercept. My y-intercept is 8. So I would go up 8, 1, 2, 3, 4, 5, 6, 7, 8. There is 1 point, my y-intercept. Now for the x-intercept, it takes a little bit more work. Because if you cover up the y, you see that that equation is just going to be set equal to 0. So it would be x squared minus 6x plus 8 would equal 0 for my x-intercept. So we could solve this in a few ways. This one looks like it's factorable, so maybe you factor it. This one, you can always do the quadratic formula. I think all of these are probably going to be factorable because otherwise you might get a decimal. I don't know, maybe not, but we'll have to check. So I look at this and I see it factors easily. Remember, if my third sign is positive, I adopt the sign of my second for both parentheses, so it's going to be x minus something and x minus something else. The factors of 8 that add to 6 are, of course, 2 times 4 is 8. Those also add to 6. If I set each factor individually equal to 0, I get x equals 2 and x equals 4. So with these x-intercepts, sometimes you'll get no x-intercepts, sometimes you'll get one x-intercept, sometimes you'll get two x-intercepts. This time we got two x-intercepts. One is at positive 2, so that would be right here. And one is at positive 4, that would be right there. Okay, so now remember, this is my vertex, so it's a mirror image, which makes sense because look at that. If you were to draw if I were to draw a dotted line between here, that would be my mirror image. So you see those are one away. So that means I would have a mirror image of that green y-intercept. That's going to be the final point that I plot to give myself a nice smooth curve. So I see that from my vertex, it is 3 to the left of my vertex, kind of. You see what I'm saying? It's 3 to the left of the mirror. So that means its mirror point would be 3 to the right over here. See how that lines up? And then all I have to do now is just connect all of my points. I want it to be nice and smooth, so don't make it all jaggedy. I forget how they do it on my math lab. I don't know if you choose the graph that matches or not. But make sure you are graphing your graph, or else you're going to be out of practice. Don't just pick it if it is multiple choice. I don't remember what it is, though. It might be actually plot your own graph. Okay, so we've graphed our parabola. The only other thing is I just want to talk about the domain and range. So the domain of any parabola, by the way, it's going to always be all real numbers for the domain. The range, however, is more interesting. Okay, so the range, remember, deals with the y values. Because our graph opens up, it goes from one point and goes up, my graph is going to be greater than or equal to. If it were an upside down parabola, it would be less than or equal to. So it's going to be greater than or equal to what's the lowest y point. So you're always going to be looking at the vertex. Okay, what is the y part of the vertex? So remember that point, it was 3, -1. So what's the y part of that vertex? -1. So it's everything above -1, right? It starts at -1 and it goes above -1. This graph starts at -1 and it goes above -1. So that's why the range is greater than or equal to -1. Okay, let's look at number 2. We'll do it together as well. So start with the vertex point. You do the vertex by doing the opposite of b over 2a. So vertex. The opposite of b would be 3 over 2 times 1 is 2. So I get 3 over 2. I'll probably use the decimal form for graphing. It makes it a little bit easier. 3 divided by 2 is 1.5. Okay. For the y part, I would probably pull out my calculator for that. So, and then I just got to remember, just plug it in for the x. So it'd be 1.5 squared minus 3 times 1.5 minus 4. So that says that's negative 6.25. So I've got my vertex. Let's go ahead and plot that. So over 1.5, down 1, 2, 3, 4, 5, 6.25. 6.25, somewhere about, right about there. Okay, and then the y-intercept is very easy. You cover up the x, anything with an x in it. So if you cover it up, what's it say? It says y equals -4. So my y-intercept is -4. So that's down 1, 2, 3, 4. Now remember, this is a mirrored point. It's a little bit tougher because it goes right through the middle of that. Right, that's my vertex, so it's a mirror. So this is left 1.5. So if I go right 1/2 and 1, that would be another point. You probably want to put that one in usually, especially on paper. And then for my x-intercepts, it takes a little bit more work. If I cover up my y, it would be 0 equals x squared minus 3x minus 4. But I like it the other way. X squared minus 3x minus 4 equals 0. And again, I look at that one. It's easily factorable. My third sign is negative, so remember that means it's going to be 1 plus and 1 minus. If you don't remember how to factor, either look it up and remember because it's a lot quicker, or just use the quadratic formula. It's not too slow, but factoring in this case is probably a little faster. The factors of 4 that subtract to -3 would be a +1 and a -4. If you set each factor individually equal to 0, one of the intercepts is -1, the other is +4. So -1 would be here, +4, 1, 2, 3, 4 would be right there. And again, you get that mirror, so you see that those points make sense. Next, we've got enough to go ahead and draw our parabola. Remember to try and make it as curvy as possible. Don't be too jagged. Something like that. Okay, and then what's the domain? Always all real numbers. We can pick any x value we want. What's the range? This one is the one you have to think about. So remember the range, you look at the vertex. Again, it's everything above because it opens up. And what is the lowest part of the vertex? Remember, it was that -6.25. In my math lab, they may ask for a fraction. -6.25 is -6 and 1/4. And as an improper fraction, remember bottom times big plus top. 4 times 6 is 24, plus 1 is 25. So that would be -25/4. Either of those would be acceptable for the range. All right, let's look at the back. We'll do one more together, then I'll try. You'll see if you can do number 4 on your own. Okay, I'm looking at number 3, and the first thing I notice is it's not factorable, so I'm not going to be able to do the factoring. But we'll start with the vertex. So remember, the vertex is the opposite of b over 2a. Oops, sorry. The opposite of b over 2a. So the opposite of b would be -2 over 2 times 1, still 2. So -2 over 2, the vertex for the x part is -1. And then you just plug it in to find the y. This one's easy, I don't need my calculator. -1 squared is +1, 2 times -1 is -2, and then it says -5. So 1 minus 2, that is a -5. 1 minus 2 is -1, minus 5 more is -6. So my vertex is at -1, -6. 1, 2, 3, 4, 5, 6. Okay, so there is my mirror. So maybe if you want to, you could draw the dotted line to help you remember that that is the mirror. Okay. The y-intercept, very easy. If you cover up the x terms, it says y equals -5. So my y-intercept is -5, so down 5. 1, 2, 3, 4, 5, right there. So again, remember, use that mirror. If this is 1 to the right of the mirror, the other point would be 1 to the left of the mirror. Okay, and then the x-intercepts, you take that quadratic, set it equal to 0, and solve that. Now again, this one's not factorable, so I do the quadratic formula. The opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. And do the math in here. That would be a +20, so 4 plus 20 would be the square root of 24. So I've got -2 plus or minus the square root of 24 over 2. So that's kind of gross, but I'll just type that into my calculator as is. I'm not going to simplify that square root. I know it's simplifiable, but it doesn't really make a difference. So I'll do negative. Remember, it's good to put the top in its parentheses so that you can just retype it in. -2 plus the square root of 24 all over 2. So one of my x-intercepts is about 1.4, 1.45 to be more exact, but it's on paper, so it doesn't really matter. And then the other one is -2 minus the square root of 24 over 2, which is about -3.45. Okay, so that's pretty gross, but we can get pretty close to that. 1.45 is very close to 1.5, so just put it about there. And same with -3.45, it's close to 3.5, so 1, 2, 3.5. Those are my x-intercepts. Now, on my math lab, you probably won't be able to plot those exact points. So since you know that these are there, you could plug in, x for x to be 1 and get a solution by plugging it in. So what's 1? If you were to choose to plug in 1, another point you could choose is 1. So that would be 1 squared is 1, plus 2 is 3, minus 5 is negative 2. So one of the actual points is 1, negative 2. And then you could also plug in over here negative 3 if you wanted to. 1, 2, 3. Negative 3 is a good choice. Negative 3 squared is 9. 2 times negative 3 is 6. 9 minus 6 is 3. And 3 minus 5 is negative 8. What? 9 minus 6. 3 minus 5. Oh, 3 minus 5 is negative 2. 3 minus 5 is negative 2. So you see those make sense because they are mirrored images. So why did I pick those? Because this point was just to the right of that. Another good point would have been negative 4, or to the right of that one would be 2. Those would be fine as well. I can show you those. If you chose to plug in 2, 2 squared would be 4, plus 2 times 2 is 4. 4 plus 4 is 8. 8 minus 5 is 3. So when you plug in 2, we get 3, right? 2 up 3. And I bet if you plug in this one, you would get 3 as well. So you can do more points. If you wanted to do another one, you could plug in 1, 2, 3. You could plug in 3 and get another point. It would be somewhere up here probably. But, you know, whatever you want. You want to do that one? Sure, why not, Mr. Clay? Oh, I appreciate it. Reardon, no problem. 3 squared is 9. 2 plus 3 is 6, so 9 plus 6 is 15. 15 minus 5 is 10. So when you plug in 3, you get 10. 1, 2, 3, plug in 10, and that means this would be 1, 2, 3, 1, 2, 3, 4. This one would also be 10. Cool, huh? Look at that parabola. What nice looking parabola. Again, try and make that as curvy as you can. Don't make it all rigid and pointy. It's a smooth curve. All right, we've got our parabola plotted. It looks great because we put so many points on it. Domain, you know, is always all real numbers. You can pick whatever x value you want. The range, you look at your vertex. What is the y part of that vertex? Since this one opens up, it is again greater than or equal to. I didn't put any negatives on there, but if it's negative, remember it's going to be less than or equal to because it would go below that point. And what is the y part of the vertex? Negative 6. So it's going to be everything above negative 6. I don't know why I drew a parenthesis, but that's okay. All right, pause the video, try 4, see if you can get it. All right, let's see how you did. Vertex is the first thing you want to start with. It is the opposite of b over 2a. So the opposite of b would be negative 4 over 2 times 1 is 2. Negative 4 over 2 is negative 2. If you plug that in, negative 2 squared is 4. 4 times negative 2 is negative 8, and then minus 7 more. So that's negative 15. 4 minus 15, negative 11. So my vertex is negative 2, negative 11. The graph wasn't quite big enough, but that's okay. It would be there, 1 below 10. Okay. Hope I did my math right there. I did. I'm so smart. Okay. Y-intercept, nice and easy. Cover-up method, cover up the x terms. The y-intercept is negative 7. I didn't draw my vertical dotted line to remind me of my mirror. There you go. Okay, so my y-intercept is negative 7. 1, 2, 3, 4, 5, 6, 7. So that means there would be another point 2 to the other side of the mirror. So there's 2 points. X-intercepts. You get those by setting the quadratic equal to 0. I'm looking at this one, and it was not factorable. So you could do the quadratic formula if you wanted. The opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. 2 times 1 is still 2. Do the math in there. That's positive 28. 16 plus 28 is 44. The square root of 44 does simplify, but I'm going to end up typing it into my calculator, so I'm just going to leave it and make fewer mistakes that way. Okay, so in my calculator, negative 4 plus, oops, I forgot to put the whole thing in parentheses. Negative 4 plus the square root of 44 all over 2. That's about 1.3. So x is about 1.3. And negative 4, oops, not that, negative 4 minus the square root of 44 all over 2 is about negative 5.3. Okay, so those are my x-intercepts. Positive 1.3, right about there, and negative 5.3. 1, 2, 3, 4, 5.3. So again, maybe you want one more point. Let's get one outside of this one. So that would be, let's plug in 2 into our equation. If you plug in 2, I'm going to do that in orange. Plug in 2. Why did I pick 2? Because that's 1 to the outside of my parabola that I already have. If I plug in 2, 2 squared is 4. 4 times 2 is 8. So 4 plus 8 is 12. 12 minus 7 is 5. So at 2, we're at 5. At 2, we are at 1, 2, 3, 4, 5. And then just to the outside of this one would be 1, 2, 3, 4, 5. I know where it's going to be, though. It's going to be at 5 because I just did the other mirror point of it. So that's good enough. Maybe you want one in here, maybe not. You could if you wanted to. I probably wouldn't. I just go ahead and connect it. Remember, try and make it as curvy as possible. It's very straight until it gets really close to that vertex, and then it really starts to curve, and then it really curves, and then it gets pretty straight. But it ever so slowly gets steeper and steeper. Okay, beautiful looking parabola. You know what the domain is. You can pick whatever x value you want. The range, again, it opens up. We didn't have any open down one, so it's going to be greater than or equal to. If it opens down, if it's an upside down parabola, it's going to be less than or equal to. And what is the y part? Remember, range is y. What is the y part of the vertex? We've already got it written down. Negative 11. So there it is. Let me know if you have any questions on this. It takes a little bit of work, but you've done it all before, so it's just kind of mashing a lot of stuff together. Good luck. If you need help, please reach out to me on my math lab. By the way, it's my birthday today. See you later.